Welcome to this video in the electrochemistry topic on electrochemical cells. So we want to try and understand the components in an electrochemical cell and why each of these components is actually present. So recall from last time that if we have different metals in equilibrium with a salt of that metal, so here we've got say for example zinc 2 plus ions in solution here, and in this case we've got copper 2 plus ions in solution, and we have the piece of metal, then we're going to get an equilibrium established, and depending on the nature of the metal there are going to be different numbers of electrons deposited from the redox equilibrium on the surface of the actual metal strip. Now if you need to watch a video just covering the basics of electricity, then please click the link now. But essentially what we've got here is a difference in electrical potential between these two zones here, the zinc strip and the copper strip. So there are more electrons here in the same space, and so they will tend to repel each other, and if we put a conductor in between these two, so some kind of wire, then there'll be a tendency for electrons to start to move, and they're going to move from where there are more of them to where there are fewer of them. So the electrons are going to start to move around this wire. And the basic idea here then is that we can actually use these electrons to do some electrical work. So we don't just need a wire, we could have a wire with some components on. So for example we could just have a wire here with a bulb sitting on it. So we could have just a simple filament bulb on there, or we could have all manner of other components. So instead of the bulb we could perhaps choose that we're going to connect this up to, I don't know, a laptop display perhaps. So this is going to power my laptop, or we could use it to charge your phone, or whatever it is that you're interested in doing. But with these electrons having a tendency to move here from the negative pole of the cell to the positive pole, we can get them to do some work on the way around. And that's the basic concept of an electrochemical cell. So the key is these redox equilibriums with different positions. This redox equilibrium lying a little way over to the right, but this one further over. So you get this difference in electron concentration left on these two electrodes. So that's the concept. How does this actually work in practice? Well, the design of real cells is complicated, and of course you're going to see differences and slight modifications that are done for efficiency reasons, and various technical challenges that need to be overcome to make cells of good lifetime and so forth. But the basic idea that what you need in order to complete this circuit is some kind of electronic conductor, a piece of metal, so a wire, which acts as an electronic conductor, and what's also just popped up here is something called a salt bridge. And this is essentially an ion conductor. Now, proper salt bridges would be made out of some kind of saturated ionic solution, usually embedded in some sort of jelly so it doesn't move too much, because you don't want much mixing between what's in the salt bridge and what's in these beakers here. And that's why you've also got cotton wool on the ends of here, or sometimes it's porous glass, just to prevent too much mixing between the salt bridge components and what is in these electrolytes. But essentially the salt bridge is allowing passage of ions across, and if that weren't there then you wouldn't be able to complete the circuit. So an ion conductor salt bridge, an electronic conductor. Now a salt bridge you can just make from a piece of filter paper that's been soaked with an electrolyte, which is probably what you'll do if you use it in a laboratory. So that's what you need to make a cell. Tune into the next video to see how you calculate the actual potential difference, so the amount of energy that you can get out of the cell.